Sorry, do you have the X kernel?
Yeah, I do have the X kernel.
Okay.
Okay, for people joining this meeting, this is an incremental language development discussion for a future version of Wolfram language. And we have a variety of topics. Let's start off with the first one. Coordinatization of arrays. What on earth does that even mean?
Yes, I suggest we go to the or main or examples.
Okay. This one I don't need the X kernel, or do you think I should run the whole thing in the X kernel?
No, for this, you just need to, there are initialization cells. So no, go to sorry, the second main. It's a bit confusing. Yes, that one. So this is a function that we have discussed in the past, whose purpose is to take an array of data and prepend coordinates.
Yes.
And so we need these sometimes for numeric data, for geopositions, for dates, quantities, etc. And I just wanted to confirm the name, the syntax. So,
right.
So there are examples. Perhaps it's clearer by looking at the examples. Yes, just evaluate and it has initialization cells.
I'm not horrified by the name coordinatize.
Mm-hmm.
What do you think?
There is a list there of other names we considered the last time we discussed this.
Mm-hmm.
I do like a single word.
Yeah. I mean, it's really what it's doing. It's adding coordinates to things. I mean, you know, in even in our purest sort of physics point of view, this is not that wrong.
Mm-hmm.
Okay. So the default, so in other words, what we would be doing here is instead of map indexed, you could be saying map something onto the coordinatize of this. Now, I suspect there's another thing we want here, which is a function. I mean, I suppose in the end, it becomes awfully like map indexed, but it isn't quite like map indexed. Oh, is that what you have? Oh, look at that. You've already got this. What do you know?
Right. So the third argument specifies the type of structure you want. And this is some sort of, I want rule. I mean, it's not fully general. It's just naming the main cases that are needed. For example, the next one, I think is important. If you go scroll, right? So sometimes we want to flatten those coordinates in front of the value. Sometimes we don't want to flatten. And I'm not sure how to call it. I'm calling it right now here pair.
Well, I mean, so the first thing, I mean, if we would just write that, what is the function? I mean, in this one, let's say that what we fed in to a function f was the coordinates and the value, right? So this one is correctly just called rule.
Yep.
This one here would be called list, right?
Right.
Let me just save this in the right place. Where do we save these? We really should have a separate folder for ILD here. Oh, we do. Okay. So, okay, so that's the list. So now the next case is the flattened case, right?
Right, yes. So here I was reserving list for the flattened case, but perhaps we don't need a name for that case. Could be the automatic case.
Well, what is the flattened case is just, I mean, it is in fact, you know, this flattened case is actually flatten at star list, is it not?
I see. Yes, it is. I see what you mean.
I mean, because it's the automatic case, you know, people aren't going to type that.
Right.
I prefer just having a function, especially since those two cases are just rule and list.
Is the flattened case just append?
It is, isn't it? You are absolutely correct.
Mm-hmm.
Okay, now what about this association thing there? That's a little different, right?
Yes. That's combining. I mean, if you're going to go the function way,
And we have
this
to
could
have
be
an F and a G, like an
exactly.
inner.
Exactly. That's what I was going to say.
I mean, so that becomes rule, comma, association.
Right.
That's a little annoying. I mean, we could have a string name for that case, possibly, but I don't think it's terrible.
Okay.
All right, now.
Right. So this is the scenario in which it becomes useful. So, for example, to coordinatize the results of geo-elevation data.
Yeah. And why is it that we would not have it on a blob like a quantity array, on something which is the result from geo-elevation data? Why not have it understand, why not have it look at the blob and automatically coordinatize based on what it can see in the blob?
I don't understand that. You mean geo-elevation data doing that operation already?
No, I mean coordinators of geo-elevation data. Okay, let me understand a couple of things here. By the way, what's the relationship of all this stuff to sparse arrays? By the way, this form here, the fact that I can say association, rule, comma, association, allows us to also say rule, comma, sparse array here, correct?
Yes.
Is that true actually, or is that not correct when we have negative numbers there and things? Well, I think it depends on what those numbers are. But Dane on our live stream is asking, could the second argument be a function? These are functions. This is exactly what this is.
Right. Yes. So in principle, I mean, I'm using integers here, but the coordinates in general will be reals, and that wouldn't make sense in association. And sorry, in sparse array.
Okay.
Right.
Okay, let's talk about the spec for the coordinates. So is this a coordinate bounds?
Exactly. Yes. So this is the flexible thing that you may want to specify arbitrary ranges. In a sense, this is a bit like the inverse of coordinate bounds for those two coordinates.
I agree. But I mean, what is this? Is this coordinate bounds or what is it? Bounding box, coordinate bounding box. Which one is it?
It's the bounds notation. So it's each one is a range. So
for the x coordinate and the y coordinate.
Exactly. Yes.
Okay, and and knowing how to divide them is a matter of. I mean, if I said 2, 10, I'd get fractional numbers there. I wouldn't get fractional numbers.
Well, in this case, you have 2.
I didn't understand that. I'm saying if this is okay, if I say 1.8,
if you do 2, 3, you'll get it, Stephen.
Right.
Yeah.
Okay, but the basic point is this is the range of values, and so what is going to happen is this is using essentially subdivide, if I'm remembering correctly, to determine what the actual coordinate values are. Correct?
Yes.
Okay. So in the case here, where I mean, this is very, 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 very messy.
So this is just the handling of I want my values centered at a cell. So that's why the dx is just a little bit of offset.
Okay.
So for example, this value this array of elevation data for the whole world of 256,512 points are cells, are like
Yeah, I get it.
cells. So,
But the thing I'm concerned about here is that, okay, I got multiple points here. First point is, in a time series, for example, starting and ending time. So this would be, you can extract from a time series its start and its end or something. Okay, so what are the cases? All right, so these are the data values. By the way, there's no mechanism here to make those logarithmic values, for example. Right, you'd have to go in subsequently after you coordinatized Euclideanly or whatever, and go and make a scaling function.
right.
It's possible that coordinatized should support a scaling function, just like graphics does.
Yeah.
Somewhat like the way that yeah, let's see. So, right, that would be a nice thing to have. Now, what other things are there that ticks allow in terms of picking their values? Because this is essentially a ticks-like specification, if I'm not mistaken.
You're right. That's a good point. So perhaps we could accept a list of axis objects, and this would immediately put the things in the corresponding ticks or something like that.
Yeah, it's a good idea. I'm a little confused by exactly what that would do, but something like this is a good idea. Okay. So Nick is commenting, coordinate here is like an adjustable version of position. Yeah, it's like map indexed, except that you are giving it. I mean, an interesting question is, how does coordinatize interact with map indexed?
Well, if you don't specify the second argument, it is effectively map indexed. But if you want to specify the ranges, then this is more flexible than map indexed.
For sure. But I'm saying if you wanted map indexed, if you want a map index to operate with ranges, so to speak, what would you do?
Oh, the function in the first argument taking the position would have to do some sort of rescale.
Yeah, exactly. But I mean, so in other words, if map indexed finds that at that level there are 18 elements that it is about to map across, it could, in principle, there could be a wrapper, much like the well, how could it work? How could it work? No, it couldn't work without map indexed having a third element that's fed to the the function that it is applying, telling it what the overall range is for that level.
Right, but one wonders, I mean, maybe you could have a map coordinatized or something that would do this.
Yes.
That would be just like map index, except it'd have the extra argument for the bounds, which I think would actually be easier to understand than this.
Then you would require a mapping function.
Yeah, you'd have to put in a function.
Well, I mean, so I think this is a useful function, by the way. I mean, but map coordinatized is not totally coordinatized. So that would be a function f and an expa there. And if you map at level 2, for example, it's going to know. So let's say you map at level 2 and there are, you've got a list ABC and you've got another list AB, X, Y, Z. Then it's going to know that one of those is You get what I'm saying? One of those is less.
But where do we say that we are mapping over angular degrees? So
Yeah, I think you need a bounds argument in there.
right.
I see, but the default case. Okay, so the default case of this is just the equivalent to map indexed with list.
Yes.
Mm-hmm.
So if I just said,
You would have to use reverse applied.
what do I have to use?
Wrap list in reverse applied, because you see it, we want the coordinate before the value.
Okay. Okay. Although in this case, you're doing the flattening here. But
Right,
if I were to do a
default it
coordinators with list. Okay, I want to address a different issue, which is what does geo-elevation data? So let's say geo-elevation data of, I don't know, Idaho. Okay. So this is presumably going to return to me. What is this going to return?
So this is first downloading a polygon, and then it's finding a good resolution for that polygon and returning an array, but it's just an array of values. Now, this is the problem. This doesn't have coordinates.
Right. So the question is, could this have metadata, this quantity array have metadata, so that I could just do the one argument, coordinatize, and that would add the appropriate metadata, that add the appropriate coordinates.
I see what you mean. So for the very particular case of geo-elevation data, we found another way, which is there is a third argument specifying the type of output you want. And the second argument is the type of elevation. So if you say here, comma automatic, comma geoposition, it returns something that contains coordinates. Right? So now the geoposition contains triples, latitude, longitude, elevation.
I see, because geoposition can have a z height in it.
Exactly. But this is very special of geo-elevation data. If we had some other, I don't know, magnetic something, and we needed some other coordinates which are not lat long, we couldn't do it. Or if we have already the array, if the array is what we start with, yeah, we don't have that information you're looking
Well, but so I think we need to understand these flows, because, for example, if I say something like population of Spain, okay, I get this, I accept it, and then I say dated here all. So now I get a time series. Well, that time series is all hunky-dory. I mean, that's already got essentially coordinatization in it. The issue is, what if I had done values of normal of that? What the heck? What happened here?
I think you want values of the time series or normal.
Oh, I see. Values of the time series. Yeah, okay. Values of %73. Okay, fine.
Right. So normal of the time series would be the coordinatized form.
That's correct. But then the values, or a coordinatized form, because actually normal, I'm going to check one thing here, which I hope is correct, that, oh, come on. This is another bug to report. These should be granularized by year.
Yes. Time series doesn't understand granularity yet.
I hope you're in the time series meeting tomorrow.
I don't think I am.
Well, you need to insert yourself there. Can we make sure you're there? Because that's an important point about granularity for time series. Okay, well, anyway, so that's the point there. Okay, so you're saying in this case, that normal is precisely a coordinatized form. It's precisely coordinate, the flattened coordinatized form.
Right. So ideally here we would have coordinatized of the list of populations, comma, a pair of dates. It would return exactly this.
Right. Right. Except, okay, yeah, that would be hunky-dory if, wow, it's dates in the future. It will be hunky-dory if these were equally spaced,
Right.
which they're not, in fact. So it's going to give silliness, but there's nothing we can do about that. If you've lost the data, you've lost the data. Okay, so the question is here. Is this a special case? This thing where you're going? I mean, this is just generating the coordinate bounds, and this is kind of a yucky way of generating the coordinate bounds. But I mean, okay, let me ask this question. Anything that can occur in range can presumably occur. No, anything that can occur in subdivide can occur in that. So if I say subdivide, what is it called? Subdivide. Of, let's say, year 1600. Why doesn't that give a yellow box? That's another bug, please. To year 1650. Okay. And then I'm subdividing by 1 year, right?
I think, no, here, that would be range. You would have to say the number of segments you want. So
Okay,
10.
right. Splatteroo. Not good.
Yes, I think we haven't prepared for this case of dates.
Okay, well, so let's understand the range case.
Yeah, so here you would say quantity one year or 5 years, yes.
Hunky-dory. Okay, so this case was wrong, but this is fine.
Mm-hmm.
So this case has to be got right, and then coordinatize would work with dates.
Yes. Yes.
Okay,
so
let me ask another question.
Yeah.
Okay, so I think that's one case that should work. The other case that should work is coordinatize of a list, well, of an array, comma, geoposition 1, geoposition 2. Right, so in other words, those geopositions are implicitly specifying transposed 2-level represent, XY coordinate ranges. Do you get what I'm saying?
Yes, we could. I mean, we enter a bit the discussion of bounds there versus bounded boxes.
I know that. But in this case, there's nothing else this could mean.
Yes, I guess so. But it will be very special of geopositions.
Correct.
An exception
yes.
for geopositions.
Well, that's because, the question is how special is space relative to all possible, things that can be represented with 3 coordinates or something. I think we'll admit that space is somewhat special relative to, I think it's okay. In the Astro case, I can imagine some 3-dimensional thing here. Mm-hmm. Okay, but the array. So yeah, okay. Are there any other special cases we need to consider here?
No, I think quantities, dates, and geopositions are, apart from numbers, of course, are the main things to support.
Okay, Nick is suggesting map coordinators can accept a function that accepts a coordinate in its second slot. Right, exactly. That it would accept not the index position, but the coordinate position. Correct. Right, guys? Well, no, it's map indexed is always using the raw part number position, but map coordinatized would accept the coordinate position rather than the, by the way, I could imagine map coordinatized being a useful function for mapping over things like time series. That's a separate discussion where it could
And
automatically pick up the coordinates from the actual structure like the time series.
I don't yet understand the need of the mapping function, because I mean, here we would have values and coordinates. I would expect more like having a function that maps directly on coordinates and computes the field at that point. But the array is already the field.
Fair point. All right, look, let's go further with coordinators and let's see if we can nail everything with that. Okay, let me just understand the map coordinators again. Yeah. Okay, so you're saying the issue is this. Let's take this case here. Well, I mean, your point is you need to specify more for this anyway.
Yes, the bounds are needed. That's the fundamental. So this function is a bit like a cousin of rescale.
I guess. Yeah, that's right. It's like putting a rescale into the part number specification. But my point that the unique thing here, which perhaps is not relevant, is that in this case where you go at level 2, okay, even if I didn't, no, I see. If I gave bounds here and I said this is always going from 0 to 1, but there are 3 elements here and there are 5 elements here, right? Then this would end up with different coordinates. This would be the equivalent of, so in the map indexed case, what this would be is map indexed. I mean, it's a little bit tricky, right? Because I've got to be able to say, in here, I've got to be able to say, basically, it's a map indexed of a map indexed of list, comma, or F, it doesn't really matter, F, comma, and then here, it's, well, it's this is a mess, right? Because I've got to have a function there, function of X. I'll be really happy when Code Assistance gives on the possibility of adding this without having to think about adding it. You got where I'm going here. You got to have something which is hash, comma, hash 2 over length of X. Map indexed over X, and then that thing there. Okay, like that. See what I'm saying?
Somehow these are independent calls. So I think what you are doing is having a separate coordinatization for each vector.
That's right. Well, and so you say, why not just map the coordinators over it?
Yes, each one with the bounds needed. So the view I was suggesting requires something rectangular in the first argument.
Yes.
And that's why it gets the values of the coordinates. The output can be rugged, which is the discussion of the next section.
Okay. All right. Okay. Okay, fine. All right, this looks good.
Okay, so then we continue with coordinatize, and I will implement these various cases you suggested here.
Okay. Gregory is commenting a subdivision method as a substitution subsequent to dividing. I think that's a different issue with adaptive subdivision and so on, which is not what we're dealing with here. All right, so let's.
Okay, so this is a
thing
more
here. You say I need to use the X kernel. Is that right?
Yes.
Okay.
So this is a more general discussion that we started, a few months ago, and Rob has extended it, and it's now more powerful. So the general idea is those cases in which we have an array which is not fully rectangular, but almost. It has some sort of ruggedness somewhere, but it's still pretty regular. So how can we find it? And how can we describe that regularity? And how can we perhaps even impose it back in some data?
Okay. So what are you saying here? So you're saying I'm a little bit confused here.
Yeah, so imagine all these cases. So these are just examples in which they are not rectangular, they are rugged,
Mhm.
but still there is a rather strong structure, right? We feel it's pretty regular. So
Yes.
dimensions is not going to be able to capture that. So
Well, let me just understand in what
yes.
sense. Okay, so if we imagine, I mean, okay, so let me make a naive thing here. Okay, so
Yep.
we do this. I've got an idea here. We do this and we say, let's see, I want position in that of underscore symbol. I see. All right. Okay. I understand. I think. I mean, I'm trying to think about this in terms. Go ahead. You have some kind of calculus for thinking about this case.
Right. So these are examples of how ruggedness appears frequently in our computations, and sometimes it is rugged, but not much. So for example, the first two cases, which are the cases we were discussing before, are very regular because all elements of the list have this structure of per comma value.
I understand, and that regularity, in a sense, what's happening is there is a pattern for the part numbers,
right,
that appear.
So what we want is some sort of generalization of dimensions and the calculus of dimensions that is able to represent that structure.
Right, but the thing that I just said is, I think, the right comment, which is there is a pattern, a simple pattern in our sense of a pattern for the part numbers that appear. Is that a true statement or not? Rob?
You might be able to express it as a pattern. Yeah.
Okay. All right. Okay. Let's keep going then.
Yes. So these are just more examples. So it appears in interpolation, for example, interpolation input. Or for example, in polygons, we have these arrays in which we have lists of values. So here the regularity is at the deeper level. So it's just rugged arrays of vectors.
All right. Let's see the, well, okay. What is almost right? Okay. Okay.
Yeah, so this is a case in which it's almost regular, but the very last one is not.
Right. So it's like a partition with an up to.
Exactly. So how can we describe cases like this? Because dimensions is going to give up immediately, and it will just say, I have 4 elements.
Yeah.
Okay, so this is what we suggest. So yeah, so you can evaluate this if this is the X kernel.
It is the X kernel.
Yeah. So,
Okay,
so
so that's an
dimensions,
ordinary case.
Yeah, that's
so let me try doing something where I start smooshing this array.
Exactly. Ugh. So let's see. So we will discuss the syntax, but this means I have 2 vectors of length 2 and I have 1 vector of length 1. This is read from right to left. So the dimensions is on the left-hand side of the rules, then the multiplicity on the right-hand side of the rule.
I mean, in the pattern language, it would be repeated.
What would this be in the pattern language? So this is saying this here, what does this really mean? Ragged dimensions. What this really means, it's an outer product of, okay, in terms of the part specifications, the part specs here above are outer products, basically,
yep.
of range, blah, blah, blah. Right? So in particular, what this is, isn't there another form of outer list? What is outer list anyway? Isn't there something else that means outer list? Some kind of tuples thing. Okay. So that with certain flattening, right, is the collection of part specifications. Correct?
Yes.
Okay. So in general, what we're trying to do with dimensions or something generalizing dimensions is it is a summary of a collection of part specifications. So for example, I'm not very clear actually let's do a catenate of this. Okay, so now what is the pattern that would represent this? It's a little bit messy, isn't it? I mean, it's basically something like X blank, Y blank, slash semi 1 less than or equal to X less than or equal to 3.
Yep.
And 1 less than, actually, whatever it is, less than or equal to X less than or equal to 3. Oops. Okay, 1 less than equal Y less than equal 2. Okay. Correct?
That's correct. Yep.
Okay. All right. So now here, we've got a slightly more complicated pattern specification where we could say this together with, well, it's not quite right. I mean, it's okay. Well, with an alternatives, basically, to specify that case.
So the idea of rugged is simultaneously doing two things. One is expressing ruggedness, and the other one is repetition. So we are interested in both the dimensions, the fact that we have objects of length 2 and 1, rather than all of them being length 2, and also the number of times each one is repeated. So that's a new idea that becomes powerful, for example, with examples we have further down.
Okay.
So,
All right. Okay.
Look at this case, for example, in which we have this matrix produced by coordinatize. So there we still have two levels, which are fully irregular, the 3 and the 2. Mm-hmm. But then inside, what we see is that we have pairs with one vector of length 2 and one scalar.
This case here. Right.
Yeah.
So, okay. So you're saying this means this level is a pure, see, I'm a little bit confused by this because I think, okay, what you're trying to do is you're trying to summarize as you go through each level. So think about this as a tree, mm-hmm. right? What you're saying, so that's a different kind of representation. So if I take this and I say expression tree of that, mm-hmm. By the way, we have to get a way to do this so that it doesn't have labels in it. Do you know how to do that? Is there a way to do that?
We discussed adding another structure, like an optional second argument to expression tree just for the case of nested lists.
Yeah, okay, but I just want to easily be able to say vertex labels arrow none and just get rid of that stuff and just have the structure of the tree.
We will add options soon. At the moment, we have to map null.
So in a sense, what that those previous dimensions mean is that structure is repeated, you know, so along that last row, you have exactly the same structure repeated over and over again at level 3.
Right. So, but this is saying, as I go from the top of the tree, right? Mm-hmm. Then the first thing I'm saying is that this is a full level with three things on it.
Yep.
And then I'm going to a full level with 2 things on it. And then here, so in a sense, this is something we could also imagine describing trees with, right? At this level, there are some elements. You're saying that everything is, I mean, if over here something different happened, but this is saying every subtree is identical here, right?
Yes.
So this is essentially you know, what you're saying is previously it was what are those things called? A complete tree. What are those called? A complete, what the heck is it called when you have a tree which has identical branching at every level? I'm not sure. but a uniform tree of some kind.
Balanced.
Oh yeah, that's what it is. It's balanced, right? So then this is saying there are identical subtrees. I'm now going to describe this. So the naive thing that I would do is to go up from the bottom of the thing saying, is everything an identical subtree? If it is, I just need to count how many elements there are at that level, right? If it is, but here, there are things which are non-identical subtrees. Make sense?
Yep.
Okay, by the way, I'm noticing on a live stream, Ali has been asking about bug tribunal, bug sessions. I've been wondering about that too. So I've been asking about this repeatedly myself. So at least, yeah, we should get this done. That's something for Addison to go chase with Unode and people. I don't know why that hasn't happened. So I'm keen to have that happen as well. And in particular, because it is a time of year when I'm about to dive into my few weeks of extreme professoring with our summer school and summer camp, and this year also a middle school summer camp. That thing should get done before I go and play professor for a few weeks. Extreme professor, I would say. It's much more extreme when it's a question of figuring out how many will it be this year. Oh my gosh, it's like 120 projects. It's like you're fed 120 graduate students in 1 week. Just yeah. Anyway, okay, irrelevant. Okay, but so I think this is a good way to think about it in terms of subtrees, if I'm not mistaken. And Nick is pointing out that it matters that this is the big subtree comes first and the little subtree comes next. Okay, so let me just understand, what is list reshape?
Right, so this is the function that would take data and would reshape the data into the given shape.
Okay, so tell me what that means as a tree function.
So
yeah, this is a good idea. This is definitely a good idea.
Right, and Rob has some examples there.
So sort of what it means from a tree point of view is you consider the tree structure, and you do a depth first traversal of that tree structure, and every time you hit a node, a bottom node, you grab an element from that flattened list, and you put that into the result.
I'm trying to understand that. I mean, the thing we're trying to describe here, okay, here's a way to think about it, okay? In list reshape, basically, what you're saying is, you do a depth first traversal, you get 1-1A, 1-2B, 2-1C, et cetera, et cetera, et cetera.
Right.
And then this is the cookie cutter that you're trying to take that list and reconstitute it as this tree. That is, you're reading from that list, doing, I see, I understand what you said now. So what you're doing is you're taking a depth first traversal of this structure, and at every step you are progressively inserting, at every place where you reach a leaf node, you're inserting the next element from that. So how does this relate to treefold and things like this? Let's remind ourselves, what does treefold do?
Yes, I think this is something that could be mapped on a tree and sequentially insert. I right now don't know how to create this pool of data that would be inserted. But
no, but I mean, isn't treefold, okay, let's remind ourselves, what is treefold doing? Treefold is doing something, I see. Treefold is returning a list from the fold operation on the tree.
yes.
Right? What the heck? What on earth just happened there?
I have no idea.
And when I hit the syntax, well, this is the X kernel, right?
Okay. Oh, yeah.
Okay. Okay. So here, this is walking the tree,
Mhm.
using that as the thing to be folded in and producing a list. But we want the inverse operation. That is, we want to take
What do you mean producing a list?
producing an F, sorry, producing a nested F object.
Right.
Treefold list would presumably produce a list.
Right.
Is there a treefold list?
I mean,
Not
this
yet.
isn't quite like nested Fs because the second arguments don't have head F.
Okay, let's not deal with this right now, although I would like to put a little pin in the treefold list question.
Mhm.
Okay, so up here, what we're saying is we've got the plain list, and now the reconstitution. So the sort of the raggedness template. You know,
Yes.
Rob wants to treat it as just the plain list of leaves, but he wants, but we're saying we're interpreting that plain list of leaves as this thing which has non-trivial structure in the tree, non-trivial
Right,
repeating structure in the tree.
Exactly.
Yeah.
And that's basically the idea behind that packed list idea.
Yeah, I get it. So I mean, in other words, what you're doing is you're saying, for purposes of how the data structure is laid out in memory, or who knows what it is, it's just the list of leaves, but we have an interpretation of that list of leaves, just like an old Fortran array or something. Maybe it's, you know, the old, isn't that right? How Fortran did it, where you have, you know what I'm talking about, where you're laying out the whole two-dimensional array, and then you have to just index into, you know, if it's a 5x10 array, for example, you know what I'm talking about, Rob?
Yeah,
You know what?
they do it column-wise, I think.
I think
Strangely.
it's just different order, but the same idea of array.
Our packed arrays do the same.
Internally?
Row-wise.
Okay.
Mhm.
Okay, fine. All right. Okay, fine. So that's what we're talking about. We're talking about, now we have a function, don't we? That is it take list or is it something different? What is the
Yes.
function that we have that goes from a plain unraveled list?
Mhm. Yeah, the take list can partition with different lengths. But this is a lot more powerful because in a very compact notation, we can implement a complicated structure like the one you have there. That's
No,
the
I
power of
understand,
this.
but in some sense, it's a bit like, to what extent is it like take list? In other words, what is the operation that we need to do? Let's say we've got the 11A, 12B, et cetera, et cetera, et cetera. Okay, so this is another way to look at it. Instead of my pattern thing, which I'm not so keen on anymore, we're asking, what is the operation that you need to do to the flattened list to deflatten it? Right? So one thing we would do is to say partition the list, right? Partition that, wherever it is, that thing there that we might say, you know, the flatten of that, partition that into threes, let's say. Okay, great. Now, but what we want to do is we want to do a super partition in which it ends up as 1A, not the flat thing here. Is that correct?
With take list, you can change partition to take list and the 3 to a list, I don't know, 1, 2, 3, 4.
What do I do here?
Just add a list, like range 4 or range 5, or something like that.
But
So you
that's
see
not the, can I do the exact thing we're doing here? Can I get
no.
this to work?
No, that's the power of this. This is something new that at the moment we cannot do with anything else.
That's what list reshape does.
But what's the relationship to array reshape?
It's list reshape is array reshape when the dimensions are regular.
I see. So in other words, if we could feed into array reshape. Array reshape is again assuming regular dimensions, so to speak, as opposed to allowing ragged dimensions.
Yeah, and one of the points Jose makes is if we sort of, you know, start to consider these as sort of dimension type things, then array reshape could just take that sort
Absolutely.
of specification and it
Absolutely.
would work.
Right.
There are examples in the next section.
Okay.
from Rob.
Ethan is making an interesting comment here. Need an easy way to recursively add children. If you want to parse some large XML org chart for a company into a tree. I see. What you're saying is, well, I'm not sure that that's really an issue because I think we're going to have XML to tree translation. So it isn't the case that you need a gluing operation. You know, it's not like you're going to do that. That would be like saying, you know, in a primitive low-level programming language, the way that people would, you know, add elements to a list is they'd go through, you know, to translate from one list to another, they do for I equals 0, I less than whatever, I plus plus, you know, append blah, blah, blah. And I think we're saying that for trees, we should have much more one gulp operations to go from XML trees to our internal symbolic trees. Yeah, Ethan is saying we need some real-world data munging examples to show the utility of the new tree functionality. Yes, I mean, 12.3 is just the beginning of the tree functionality. Coming, hopefully, in the next version will be all the stuff for XML, HTML, etc., and many other kinds of large-scale trees. That just wasn't, you know, that's the nature of these incremental releases. That was not ready yet. Okay, but let's come back to this. So what you're saying is, you know, again, I want to repeat again what it is that you're saying. What you're saying is, because I could imagine actually using a tree as a template, right? Like rather than giving the whole ragged thing, what if I just said, my template is blank, blank, comma, blank.
But you see, it's like with dimensions. With dimensions, we can have 1,000,000 and we wouldn't have to have a model of 1,000,000 size. We just have the number 1,000,000.
No, I know, I get it. But what I'm saying is, this is saying how to turn the lowest level dimension. This is saying what that dimension is. I would argue that an ordinary dimension is a blank dimension, right? A single blank dimension. Whereas what this is saying is every element at this level, every element at level 3 is in fact not a, you know, just a pure blank underneath it. It is a this structure underneath it.
I see.
Is that making any sense?
Yes, I think it does. But
Yeah.
we wanted to gain also the repetition idea. So if instead of 2 blanks, you had 1,000,000 blanks, we want to have blank arrow 1,000,000.
Okay, I get it. So what you're saying is, that you want to represent this just as essentially 2 comma, well, okay, that's a little tricky, isn't it? Because I mean, this is a length 2 object. And this next thing is, what is that object? Is it a length 0 object?
Yes,
probably
it's
is.
Scalar. Yep.
Okay, but if I can have an arbitrarily complicated subtree here.
Mm-hmm.
And you're saying at every level, instead of saying it's a okay, so the way I would think about this is I go down this tree, I'm simply asking, I've got a level, everything's the same. Okay, I've got a level, this is now, things are different, so this is a 2 and a 0. And if I went down, can somebody make me another tree that has some more levels of weird stuff in it? Like, let's say those 3s. Let's imagine that element there. Let's imagine these elements here, these second elements here, have another tree hanging off them. Could we easily make that?
Just change those 2 ones to some list 1,0, something like that. So
I see. It's just the 2 ones.
In the original expression.
Right. So here, I want to just change this to an XY,
for example.
Right. But now I've got to do, because I've got to make it the same for every subtree. Okay. All right. So this is now the next case.
Right. An inverse way of doing it, Stephen, which is interesting, is you can take a dimension structure you want and use list reshape with the empty list. It pads to 0, and you can actually get the see what the structure actually is.
Well, you're saying that if I take this, okay,
No,
but
don't
I
take.
just want, yeah,
Yeah.
go ahead.
If you want to understand what a what structure like one of these dimension structures is, you just do list reshape, and you could take that ragged dimensions, for example, that you have above, do list reshape of empty list, comma that.
There are examples further down. You ought to see.
Oh, maybe that's, yeah. Right. And then and then you can look at the tree for the expression tree of that.
Okay.
Now you could also
That's
add
better.
another, you could copy that ragged at the end, and it would have 2 levels of raggedness.
I need that before that thing there.
Yeah.
Splash.
Oh dear. Oh, sorry, Stephen.
Oh well.
I think if you put a 1 there, a 2 there or something, it'll at least repeat that too. So that's a bug in the implementation, obviously, but no. So something's very sorry about that.
Okay. All right. Okay. Let me look at these examples here. Yeah, I get it. I get it. I mean, this is sort of the I get the notion that this is it's like an old Fortran array. It's got a way of describing what that position should mean in the original setup.
Right. It's a bit more general than the old Fortran array, but yes,
I know.
That's yeah.
I'm making a
And I think, Stephen, this could, in some of the types of examples you've had for the compiler where you have these sort of, weird structured lists, this could actually be a very powerful thing to deal with those.
No, it's a good idea. I mean, basically it becomes a type in the compiler that we then can handle.
Precisely.
Because the argument would be a decent fraction of very big structures have lots of things that repeat in them. Although it's not always the case, because I would claim there's a different case, which is, something where there's a million elements and each element is either 2 or 3, a sublist of either 2 or 3 elements. And so in other words, that's like a struct. There's a finite collection of possibilities. Instead of it being the case that everything is level-based, so to speak, that there's a finite collection of possibilities within that large list.
Right, and that would be a different. So this does well for sequences which are the same. So if you have a bunch of 3s and then a bunch of 2s, this works great. This particular thing. But if you have a finite collection, this is not the ideal data structure.
Right. So a typical case of finite collection is missing data. Right, where things are usually sublists, except they might be missing data.
Yep.
Okay, but this case is already interesting. So the real point for me is understanding this ragged construct, which I'm not initially very taken with. At least I'm understanding go ahead.
Given that it has rules, we could remove the ragged head and just have a list. It would look nicer. I think
it would actually look much nicer too.
Right. I mean, unfortunately, dimensions, well, we couldn't use this in dimensions. It would have to be a new dimensions, generalization of dimensions.
Right.
Which is fine. I mean, that's okay.
Yeah, my original name was something like generalized dimensions, and then, Jose and I came in.
Generalized dimensions is like new college or something,
Right, that's true. Yes, okay. Fair enough.
Okay. By the way, Ethan is commenting that depth first scan should work on tree. That's, I think, something for Ian. I don't know if Ian has a comment on that.
I think we discussed with Charles the idea that trees would be interpreted by the graph functions via tree graph. It may not be
Yes.
implemented yet.
Okay, but that's an obvious thing to do.
Mhm.
Okay, but I want to come back to this. Okay, so you're proposing that in this case, I'm still very confused by notation. I'm very confused by this notation. I just don't understand this at all. Why are you not just giving a thing? Why is there an arrow 1 here? I don't understand that at all. This thing just looks like it's a sublist, a dimension in which the subtree, in which basically what's happening is that this object itself is just a miniature version. It's the, I'm sure it has a name in category theory, what we're doing here.
But we want to take some sort of outer. So if we want to take miniatures, the miniature approach, which is what Rob started doing, ends up with models that are very big. So I think I have an example further down, which is rather complicated, and it's.
Well, I get it. I mean, what you want to do is be able to say, I think we're being confused here, okay? So I claim that you just go down level by level, and at each level, let's take the example of this guy here, okay?
Yep.
Okay, so in my claim, this would look like, okay, first level is 3, okay, next level is 2, right?
Yep.
Next level is a list, because it isn't one thing, and the first argument of that list is, I claim, the list 0. I'm not sure why we need these zeros. That's a little weird. Let's actually write none there, because I think that's more tree-like. Comma, none. I claim that's the pattern. That's the structuring template for that's the structuring template, and I'm modeling this over the way that tree does things, although it might not be. I might not have that right exactly. Do you get what I'm saying?
Yes, yes.
Yeah,
So
I think that 2 should be in a list, but besides that, yeah.
Why should that 2 be in a list?
Because it's a list with dimensions 2. The dimensions of that x, y.
right.
No, I don't think so. I don't think that should any more be in a list than these things should be in lists. The only reason there's a list here is because I'm breaking a level to not just be a pure number.
But it's a complete level. So when we have a sequence of objects of different dimensions, we have to consider the full dimensions of those objects. It could be a matrix.
So suppose you had 1,000,000 elements at that level, you'd have to list all of those out with your notation, even though
what do you mean 1,000,000 elements at that level?
Well, do partition of range of 101, comma 2, and then whatever the argument is to pad with the empty list. I think maybe that's the empty padding. I mean, Jose had
up to 2.
Right.
Up to
2. Fine. Up to 2. Thank you. I've forgotten that. Okay. Now do the ragged dimensions of that. See, this keeps it super compact. Whereas
I don't understand. What I'm suggesting is, I'm totally confused by your complaint here. Okay. What I'm suggesting is, in this case, I think I'm suggesting this is a list. Oh, I see what you're saying. Do I see what you're saying?
It's like, I mean, in the pattern language, this is repeated.
Yeah,
we're using rule to represent repeated.
Well, maybe we should just use repeated. If there's an interpretation in the pattern language of this construct,
yeah, perhaps repeated of list 2, 50 could work.
So then this would look like repeated 2, 50, 1. correct?
Mhm.
That will be the form of that level. So normally you'd be able to just say, in a case like this, you could just use 3, 2, blah, blah, blah. But in this case, this is the shorthand notation that avoids you having to write a huge number of repeats of that subtree.
Right, exactly. And you know, it's nice having a consistent structure. So that's why we did the rule goes to 1 to just have consistent structure there, but it's not.
I'm not sure that's the nicest thing, because I think if the more common case is that it will be that the subtrees will be quite small at the bottom and all the bigness will be at the higher levels, you'll never see that.
Yeah. But I would argue that the 2, I mean, what does that mean? It's going to be a thing of length 2. So what do you use to represent just a scalar? I mean, a thing without any length.
Well, I don't know. That's what I was using none for above. Again, I'm trying to ask, and apparently Ian isn't here. I'm trying to ask in the analogy with trees, right?
Well, actually, in the pattern language would be except of list, right?
Yes, it would be. But I'm asking in the trees case, I think we have a way of representing there is a leaf here. I guess Ian isn't here. He's listed as being here.
I'm here.
Okay, are you able to respond to what I was just saying?
I don't see the connection between a tree leaf and dimensions.
Okay, I don't think you were paying enough attention.
So
Okay.
I think the problem here is that in trees, we don't have a way of expressing repetition.
No, that's not the point I'm making. The point I'm making is that what we're trying to deal with is something which is a pure leaf, a leaf node of a tree. What's the way of representing a tree which is just a leaf node? What it is it has no subtrees, and this is the way around we're finally doing. Is that right? Subtrees are first.
No.
It's payload, comma, list.
Yep.
Okay, fine. So that's saying there is no. This is a pure leaf. That's what I'm mimicking here. This is a pure leaf, as opposed to it has sub-elements.
Yeah.
Yes, but the dimensions language itself, if you do dimensions of 3, gives you empty list, and I think for self-consistency we have to support that.
I'm sorry, dimensions of what? Of the number 3.
Yes.
Okay, well, fair enough. All right, listen, I have to go. I'm supposed to do actually another live stream. And I need something to eat before I do that. This is a very interesting thing. I feel like you haven't sold me on the precise notation that you have. Perhaps it would help. Maybe putting an association there would be a better thing. I don't know exactly. Something is very hard to read about this notation.
I like the idea of repeated, of having pairs repeated dimension, comma, number. And perhaps we just have a list, no ragged object to look ugly.
Yeah. Yeah, I think the repeated is good, because that makes it much clearer what it is.
Right. Well, let's try that. There may be some other issues with it. All right. I should run off here. Very interesting. It's a good thing. I'm very excited about the idea of being able to use this in the compiler and so on.
Okay. Well, I'll develop it a bit further, and I'll certainly try a compiler thing as I get further along.
Right. Okay. Sounds good. All right. Thanks a lot, everybody. Thanks for the comments on the live stream. And Ali, the bug event, we need to do it. Thank you for pushing it. It will get pushed. Okay.